As you look at the evolution of typical development, right, going from, say, monolithic applications to client-server applications to more complex cloud-based applications where your workload is partitioned across multiple instances running different services, right, you start to get a much more complex scenario with a lot more points of failure. And one of the things that you really want to look for is for resilient application design, right? So that if a service fails, that your entire application doesn't fail, or so that you build asynchronous applications. And one of the very common patterns that you find is a queuing-based system, right? So if I've got a front-end web application and that front-end web application needs to communicate with a service and there may be some issues with reliability or workload on the service, then rather than having that be a direct synchronous connected communication, you make it a queued communication where the web application can drop off a message into a service queue. The service queue can go pick up that pick up that message, process it, and possibly drop off a message back to be monitored by the web application, or however you break up that functionality. It's a fairly common pattern. And in fact, it's so common and so important that Azure includes natively two different approaches to queuing, and we're going to cover both of those. And the first one that we're going to cover is the storage queues. Right? And storage queues are going to give you a way that one form of message queuing, right, that allow you to access queues by from multiple clients. Right? You get reliable messaging, and you'll see that always with messaging, that it's got to be reliable. And this is built for massive scale. Now, architecturally, hierarchically, it's a pretty simple architecture. It's part of the overall Azure storage. You've got a storage account. Right, that storage account, within that you've got storage queues, and those storage queues hold various messages. Let's take a look at a little more of the details. So storage queues, and this is something that is really critical, you're looking at a large number of small messages, all right, and that's going to be important. And the queues can be consumed by a number of consumers. So I could, for example, have a web application drop off a queue, and I could have multiple processors that all compete to consume messages off the queue, and it's a way of scaling applications. Okay? Queue messages have something called flexible leasing, where a particular consumer, once a message is dropped on the queue, a consumer can access that message without pulling it off the queue, but put a lease on it, which is effectively locking it. Right? And you can define the length of that lease and what happens if that lease expires or gets renewed. Okay? Your queues, like all other storage, take advantage of your built-in storage logging and metrics so you can see what's going on with queues. And storage queues have the concept of state. And this is actually fairly unique with queuing systems in that when a message is in the queue, it can actually be updated. So you could have multiple processes that are working possibly in a workflow kind of orientation, and you're updating the state of an individual message and using that as a centralized point of communication. All right, so there's a lot of things that you can do with this. The basic concept is I've got a message producer. The message producer puts a message on the queue, and one or more consumers can access that message and process that message from that queue.